Okay, so this is Leetcode 42, and this is a hard problem, and this is trapping rainwater. Hard problem, and we're trapping rainwater. So what this looks like is, so we're given some sort of array, input array, and we'll just go with the example that they gave us here. 0, 1, 0, 2, 1, 0, 1, 3, 2, 1, 2, 1. So each block represents, each number represents a block with width 1. So with this array, you can kind of imagine it's an x and y axis. So at index 0, we have an element with block width 0, or block height 0. So we have nothing there. And then at x1, we have a block of height 1. And then at 0, so we can go just on, I guess. We don't really need the indices, really. Or not to illustrate the example. At 0, we have 0, and then we have block of height 2. Shouldn't draw like that. Another one of height 1, 0, another 1, and then now we have something of height 3, and then height 2, and then 1, and then 2 again, and then 1. And then at the end, and it just go on forever. So here we have, we're trying to count how much rainwater can be trapped within these blocks. And to the left of the first block, there's no wall there, so this can't hold anything. So a different colored marker here. So rain will delineate as purple rain for some reason. So one block of rain, and here would have 1, 1, 2, and then 1. So 4 here. So 1, 4 in this segment, and then here we would have another 1. So total we would have 1 plus 4 plus 1, which would be 6, and that's what we would be returning. So this is the example. The code's actually pretty simple. Just like in the previous video, I actually got this from programmer Mitch. I hope you can see that. Yeah, you can see it. Finally using a tripod today. So yeah, this is the example. I guess we could leave that there for now. Yeah, we can actually just leave it there. This was like this. Yeah, code's pretty short, so I think we can just draw it there. So what we're tracking is we need a left index, we need a right index, so this would start at 0, and then the length of the height array, this array, I guess, -1. Again, this is in Python, and then we need to keep track of a left wall, the leftmost wall that we're currently looking at, and then a right wall. And then obviously we need to store these counts somewhere. So we can initialize a variable called like water that's initialized to 0. And then we would just kind of move from there. So yeah, so I'm going to define a trap. Call it trap. We'll have some sort of array that represents the individual heights for each point at the x-axis. And then right here, I guess I should have just wrote that here. So left and right, we said initialize to 0, and then the length of the array -1, left wall, right wall. We're going to initialize these at first to be 0. It's very simple actually. Oops. So what we're doing here is we're gonna loop through the elements in this array, and to do this we can just and then the stopping condition is when we reach the peak of the array. So in this case it would be the 3. Yeah. So while L, and I just write the cursive L because I think it's easier to distinguish between like a capital I or a 1. So while L is less than R, so we need to first check that the left is here first, right? And then R is here. If array of L is less than array of R, and then if left wall is less than array of L, so left wall is less than array of L, then we need to update left wall. Left wall equals array of L. And then I'm gonna run through the code so it makes sense what we do too. Otherwise, we're going to add to the water. So we didn't initialize a water variable here. So I'm just gonna insert it here. Water equals 0. Initialize first to 0, add 1, and then we're actually not going to add 4 at a time. We're going to do column by column. So we're going to do 1, another 1, 2, 1, and then 1. So left wall is that, water, and then there's going to be cases where we add to water, but it's going to be like 1 minus 1, which is just 0, or like 0 minus 0 as well. So we're going to hit the cases like that sometimes, but in the end it'll all work out. So water plus equals the left wall minus array at index of L. And then we're going to do the same for the right element. So else if array R oops. Yeah, I guess I could write it that way. So if right wall is less than array at R, right wall equals array at index R. Alright, I can sit down. Else, and then I forgot a step here actually in this else statement. After we add to the water, we need to increment L 1 to the right. So here, L plus equals 1. This isn't this. That looks bad. And I think it's L right above the water. Okay. Else water plus equals right wall minus array at R. And then R, in this case, you would want to decrement R. Minus equals 1. And then once we break out, we want to return how much water we have trapped. So this might be a little confusing at first. It actually took me about 15-20 minutes to figure out why this code works. But let's see if I can explain it here. So we'll use this example. So I'm going to get rid of this purple stuff. And then return water, not just return. Right, so we're going to have water. I'm just going to write all our variables, and these are going to change as we iterate through it. So water is initialized to 0, left is 0, R is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, minus 1, which is 11. Left wall, white wall, right wall, let's call LW, RW, 0, 0, L and R. So yeah, let's go through this. So while L is less than R, which it is right now, L is 0, R is 11. If array at L, which is 0, is less than array at R, which it is, 0 is less than 1. So the left wall is 0 right now. So is 0 less than 0? No. So we're going to go to our else statement. We're going to add from our left wall, the difference from our left wall, which is 0, with the array at element L, which is also 0. So water plus equals 0. And then that L plus equal 1 is going to go through. So L is now 1. So that's the first iteration. So now we updated L. That's the only thing we did. So L is still less than R, second iteration. Array at element. And then let's move this to here, because we incremented L. So left wall is still 0. Array at L is less, or we have to go to the first statement first, sorry. So the array at L, which is 1, less than array at R. No, 1 is not less than 1. 1 is equal to 1. So we'll go to our else statement, and then we'll hit this else. So if right wall, which is 0, is less than array at R, which it is, right? Right wall is 0, is less than 1, so 0 is less than 1. So we're going to set right wall equal to the array at R, which is here. So right wall is now going to be 1. So RW is going to point here. So we can update that as well. Next iteration. L is still less than R. We haven't updated R that last iteration, or L. Alright, element at 1, which is 1. Array at L is 1, is less than R. No, R is still here, so no. We go to our else statement again. And then we check right wall, is it less than array at R? No, it's not, because 1 is not less than 1. So we go to our else statement, and we subtract the difference of right wall, which is 1, with array at R, which is 1, and we decrement R by 1. So this difference is obviously 0, and then R minus equals 1. We're going to update that pointer. So R is now 10. So now we're at here, and then we're going to go through it again. L is less than R. Array at element L is 1. Array at element R is 2. So we don't go there again. So here we go to the else statement. The right wall, which is 1, is less than the element at array R, which is 2. So 1 is less than 2. There we go. We'll update the right wall again to be equal to the array at element R, which is here. So we're going to update right wall again. It's going to now be 2. So we're kind of just moving this way right now. And then LW is just pointing to 0 right now, but I'm not showing it here. So right wall is at 2. So we go to L is less than R. Yes. Array at L is it less than array of L, is it less than array of R? Yes, it is. 1 is less than 2. So now we're on this side again. So if left wall, which is 0, is less than the array at element L. 0 is less than 1. Yes, so we're going to update left wall is equal to this element. So now we have left wall into the mix, which is 1. So boom, we're at 1. So we've updated these so far. Breakout, well, L is less than R. Array at element L is still less than array at element R. 1 is less than 2. Left wall is not less than 1. 1 is not less than 1. So we're going to add to our water 1 minus 1, which is 0, and then we're going to increment L by 1. So we go here, L is now 2, R is still 10. Go back again, array at R, array at L is 0. 0 is less than 2. Left wall is 1. 1 is not less than 0. 1 is greater than 0. So we go to our water. So now we're doing something interesting. So water plus equals the left wall, which is still at 1, minus the array at element L. So 1 minus 0 is 1. And then we're going to increment L. So we add it to the water. So now we have the 1. And then we're going to go out of this, add to the water, and increment to the left by 1. So now array at element L is 2. It's not less than array at element R, it's just the same. I don't know, like the same height there. It's supposed to be the same height. I'll just write it. 1, 2, 1, 1, 3, 2, 1, 2, 1. Right, so L is not less than R, so we go to the L statement. The right wall, is it less than array at R? No, it's not. So add to the water 0, R minus 1. So R is now here, so let's see what happens here. L is still less than R, array at L is 2. 2 is not less than 1. Good L statement, right wall, which is 2. Is it less than array at R? 2 is less than 1. No. So we go to our water, equals, plus equals, right wall, 2 minus 1, which is 1, and then we decrement R. R is now here, and I forgot to update these. 10, 9, 8. Should have been 9 and then now 8. And then water is going to be 1 plus 1, which is 2. So I'm just gonna go over everything, or until we get to here, and then you'll see when we break. So I guess, yeah, everything. So R is now here, it's at index 8, L is at index 0, 1, 2, 3. Forgot to update these. It's at index 3, so L is still less than R. We moved R in the last iteration. Array at element L is 2, and it is not less than 2. So with the else, right wall, trying to see, did we update right wall? Okay, it's still here. I may have forgotten to update it before, but let's see where we are. So L is less than, go to the L statement, right wall is 2. It's not less than 2. So right wall is going to be, we're adding to the water, 2 minus 2. And then decrementing this by 1. I may have made a mistake, but I don't think it will matter because we already passed that. Yeah, we'll see. So we incremented that to 3, which is our peak. So we're probably not going to update right anytime soon. So L is less than R. Array at L is less than array at R. 2 is less than 3. Left wall is 1. 1 is less than 2, so we're going to update it. So left wall is now pointing here. Left wall is 2. I forgot to change it before, I think. Whatever. Right wall is 3. A lot of variables to keep track of here. And I forgot to change this too, I think. Okay. So we updated left wall here. Next iteration, L is still less than R. Array is L. 2 is less than 3. Left wall is 2 less than 2. No, it's not. So we add to water 2 minus 2, and then we increment this. Break out. Array at element. So 1 is less than 3. Left wall 2 is not less than 1. So we go to our else statement. We add to the water 2 minus 1, which is 1. So now we're at water 3, and then increment this by 1. So now we're at L was 4, and then now it's 5. Element L is 0. 0 is less than 3. Array at element, or left wall, which is still 2, is less than 0. So we go to our else statement. Or not, 2 is not less than 0. 2 is greater than 0. So 2 is not less than 0. So we go to our else statement, where we add 2 minus 0 to our water. So plus 2. So water is now 5. And then we increment L by 1. So now we're at here. Left wall is still at 2. And right element L, which is 1, is less than 3. Left wall is still 2. 2 is not less than 1. So else statement, water plus equals 2 minus 1, which is 1, which is this purple box right here. So we add 1 to the water, which gives us 6. And then we increment L to be the same index as our right index. And we get to the end. L is no longer less than R. L is equal to R. And then we're going to return our water variable here, which is 6. So yeah, I think that covers it. I hope it helps going through iteration by iteration, because it helps me. Thanks.